Today we're going to talk about something new. It's called exponential growth and exponential decay. First, we're going to start with exponential growth, and that is, it says a quantity is growing exponentially if it increases by the same percent in each unit of time, and that's called exponential growth. You see this a lot in sciences, and the exponential growth formula is y equals a times the quantity 1 plus r raised to the t power. A is your starting amount. So what you're going to start this whole situation with, it could be money in your bank account, it could be how much you pay for a car, so forth and so on. R is your rate, okay? It's a percent that you will get, like here you have a rate in the next problem of 8%, and it's always given as a decimal. So if I gave you a 5% rate, to find it, or the equivalent decimal is 0.05. Okay, you always move your decimal place here to the left 2. So if you never know, move that decimal place to the left 2. And t is your time. So this is over amount of time. So when we use this formula, you will have some decimal answers. So for rounding, how you round your answer will depend on the situation. When units are dollars and years, round to the nearest hundredth. And when units are people or animals, round to the nearest whole. So your first example is you deposit $500 in an account that pays 8% annual interest, compounded yearly. Keep that equation up. Write an exponential growth model for your account's balance. Well, you have to find two things. You have to find how much you start with and your percent or your rate. So A is our starting amount, and that much is 500. Since it's growth, you would say 1 plus your percent, and 8% as a decimal is 0.08, raised to the t power. Time is going to vary. Okay, so if you look, our examples are how much is in your account after 4 years? How much is in your account after 15 years? So all you do is this represents t, time, how long. So you would say y equals 500 1 plus 0.08 raised to the 4th power. For this one, you would say y equals 500, because your amount in there does not change, plus 0.08 raised to the 15th power. Now, I do not expect you to do this in your head, so we're going to go to our calculators. Excuse me. So, what we need to put in our calculator depends on what we wrote down. We don't need the y equals, okay, but we started with $500 in our bank account, and we're multiplying that by 1 plus 0.08, which is your interest rate, raised to the whatever year. So first one was 4 years. If you hit enter, your account now has $680.24. So I'm not asking you to do this in your head, I'm asking you to do it in your calculator. The really awesome thing about these calculators is that you do not have to type this in every single time. What it does, if you hit second enter, it brings up the last entry that you typed in. So now all we have to do is arrow over and type 15 for the next problem. So after 15 years, using that same formula, your account will have $1,586.08. And that's how you do these problems. So let's do another example. It says in 2010, the salary for working at a summer camp was $1,800 for the entire summer. Each year you return to work, your salary increases by 5%. Write an exponential growth model for your salary at the day camp. So again, we need to figure out what we started with, and it's growth, so we're adding our percent of 5. So you're always substituting in two things, your starting and your percent. So what is your salary in 2012? Let t equal 0 represent 2010. So anytime you're dealing with time, whatever time you start with or year you start with, that's going to be your 0. After that is 1 year. So 2012 2 years have passed since you started at the camp, so T is going to be 2. So you have y equals 1800, 1 plus 0.05 raised to the second power. So if we go back to our calculators, we're going to have to change it because we changed our values. You have 1800 times 1 plus 0.05 raised to the 2 power, second power. So after 2 years of working, your salary would be $1,984.50. Now it says, what is the cumulative total amount you have made working at the end of 2014? This does not mean that you get to find 2014 and that's all you've made. It means we need to figure out what you made in 2010, 2011, 2012, 2013, and 2014. So we have to do this problem 5 times because it wants to know your total amount. Well, in 2010, you made $1,800. We just found out in 2012, you made $1,984.50. So now what we have to do is we have to go back to our calculator, find out how much we made in 2011, which T is 1, because here T is 0. We found out 2002. We have to do 13, which T is 3, and 2014, which T is 4. So again, our little trick, second enter, brings up that old problem, and we would change this 2 to a 1 and find out you made $1,890. And then we have to change our, hit second enter again, our 1 to a 3, and that's 2,083.73, 2083.73. And then we have to change our 3 to a 4. So second enter, arrow over so it's highlighted, hit a 4, and you made $2,187.91. 2,187.91. So to find the cumulative total, you have to add all of these together. So because I can't see them all, I'm going to just move my calculator up a little bit, if I can. Or I'll just move it around. So we start with, if I clear my screen, 1800 plus 1890 plus 1984.5 plus, now we're going to go over here, it's 2083.73 and lastly we made 2187.91 in 2014. So here we go. That means you made $9,946.14. $9,946.14 over the 5 years you worked at the camp. So that's what it means for cumulative total. So let's try another one. In 2005, a population of 20 rabbits was released into a wildlife region. It was observed that the population increased by 45% each year. If T equals 0 represents the year 2005, write an exponential growth model for the rabbits population. Well, we started with 20 rabbits, and we grew by 45% each year. T equals 0 is 2005. So how many years have passed to get to 2014? If you said 9, you're correct. So that's what goes into our calculators. So we would say, let's clear that, 20 times 1 plus 0.45, because it's 45%, raised to the 9th power. And this gives you 566.69, but since we're talking about animals, we have to say 567. We'll round up. So that grew a lot in 9 years. The difference between growth and decay is this negative. The equation stays the same, but now we're decreasing exponentially. So it's called exponential decay. So A is our amount, R is our rate, and T is our time. Okay? So let's talk about this. It says you bought a used car for $18,000. The value of the car will be less each year because of depreciation. The car depreciates at a rate of 12% each year. So we would say y equals 18,000, 1 minus, because it's going down, your amount is going down, 0.12 raised to the t power. So how much is your car worth after 4 years? And how much is your car worth after 15 years? So let's go ahead and go to our calculators. And we would say 18,000, 1 minus now 0.12, because it's at 12% to the 4th power, which your car's worth $10,794.52. So it went down almost $8,000. And if we hit second enter, whoops, let's get out of this. Second enter, we can change our 4 to a 15. And after 15 years, your car is $2,645.52. So your car went down a lot. It says, will the value of the car ever reach 0? In this case, no. Because as you're multiplying by that decimal, it's going to get closer and closer and closer and closer and closer to 0, but it's not ever going to hit 0. And it actually does in the year 5,000, but that's not logical. Okay, so it's going to take 5,000 years for your car to be worth $0. But that's not logical, so we're going to say no. We're going to do one more problem of decay, and then we're going to call it a day. So in 1999, Tommy decides to invest $4,000 into the stock market. Each year since then, the stock market depreciated 2% each year. So our decay model would be 4,000, y equals 4,000, 1 minus 2% is 0.02 to the t power. If Tommy decides to leave the money, what will the value of his stock be in 2005? Okay, so we invested money in 1999, which is t equals 0. 6 years have passed, so t is going to equal 6. So we're going to say y equals 4,000, 1 minus 0.02 raised to the 6th power. So in our calculators, we would say 4,000, 1 minus 0.02 raised to the 6th power. So if Tommy left his money into the stock market for those 6 years, he would have $3,543.37. Hope this video makes sense. Try your homework. Good luck.